In this video, I explained the deep learning shift in computer vision. After watching this video, you will be able to explain what is the difference between old school and modern computer vision. Let's take a look at the cat and dog image classification problem. In classical computer vision, image processing is used to extract visual features to perform the classification task. The input image is transformed into the feature space. That is, in our example, a black and white image featuring the edges of the cat in the image. The transformation is performed using 2D convolution. The features are then given to an algorithm that classifies the images based on some logics. For example, if pointy ears, then it's a cat. In this approach, our knowledge about the word is used to construct rule-based algorithms to understand the image. The limitation of the knowledge-based algorithm is that they are not scalable to complex vision problems. Even in rather simple cat and dog classification problem, describing cats and dogs in terms of explicit visual features is very difficult, if not impossible. Therefore, to fix the problem of knowledge-based or rule-based computer vision, the algorithm part is replaced with the learning approach, where instead of predefined rules, a machine learning model is used to learn the patterns in the feature space. The manual feature extraction is still present in the learning approach. However, we may use descriptors or feature vectors that are the abstraction of the raw features to break the curse of dimensionality. Examples of these vectors and descriptors are bag of visual words or feature vectors. In the next step, a classifier, for example, a multi-layer perceptron, is used to output the class labels. In our example, the classifier has been trained on a dataset of cat and dog images with class labels. This is a supervised learning framework. In conclusion, using a classifier that is trained to learn the distribution of the feature vectors is much more effective for image classification tasks compared to the rule-based approach. In fact, we only need to come up with useful descriptors to do a perfect image classification, as the powerful machine learning models can take care of the rest. Deep learning does exactly this. Deep learning automates the feature extraction pipeline. Instead of handcrafting useful features from the image, deep learning learns the descriptors or features directly from the raw data. That is an image in our image classification task. In inference time, the input image is given to a neural network, where the hidden layers in the deep neural network transform the image into hierarchy of features commonly referred to as representation learning. The classifier layer at the end outputs the class label. The artificial neural network in between input images and output class labels is trained on a large dataset of images with labels in supervised manner. In our example, cat and dog images. The neural network is called a deep neural network because of many hidden layers that exist between the input and the output layers to enable powerful feature extraction. The framework is called deep learning. No signal processing is required in deep learning approach to transform image to useful features. Here, all necessary features are learned from data during the supervised training process. You see how image classification is made easy using the deep learning approach. The most important factor for deep learning is the data to be representative enough of the underlying classes in case of the classification task. The major challenge in the deep learning approach is the large amount of labeled data that is required for training deep neural network. Indeed, labeled data is expensive as it requires human annotation for the images.